Good day everyone, welcome back to our discussion on the topic, the first principle of differentiation. Today we will be attempting more examples. The very first example we are attempting states that find the derivative of y equals to 1 over s using first principle. Solution. The first thing we are going to do is write down our equation y equals to 1 over s. Next we are going to add our change in y and our change in s, and as learned from our previous class, for everywhere we are seeing y we are adding our change in y or data y, and anywhere we are seeing s we are adding our change in s or data s. So our equation becomes y plus data y will be equals to 1 divided by s plus data s. The very next step is to subtract y from the left hand side and subtract 1 over s from the right hand side. Basically, we are subtracting our original equation from y plus data y equals to 1 divided by s plus data s. Doing so, it becomes y plus data y minus y will be equals to 1 divided by s plus data s minus 1 over s. Our left hand side simplifies to data y because y and minus y will equate as, and our left hand side will simplify further by solving the fraction. Doing so, it becomes s minus s plus data s in bracket divided by s in bracket s plus data s. Opening the bracket in our numerator, our equation becomes data y will be equals to s minus data s divided by s in bracket s plus data s. Simplifying further, it becomes data y equals to minus data s divided by s in bracket s plus data s. At this point, we will divide both sides by data s to get data y over data s. Dividing both sides by data s, our equation becomes data y divided by data s will be equals to minus data s divided by s in bracket s plus data s multiplying data s. The data s in our numerator and the data s in our denominator is going to equate at. So we are left with data y divided by data s is equals to minus 1 divided by s in bracket s plus data s. At this point, we are going to look for our dy over ds, which is the limiting value of data y over data s as data s tends to 0, which should be equals to the limiting value of minus 1 divided by s in bracket s plus data s as data s tends to 0. As data s tends to 0, data s will be equals to 0. So therefore, dy over ds will be equals to minus 1 divided by s in bracket s plus 0. Simplifying further, dy over ds will be equals to minus 1 divided by s in bracket s, and dy over ds will be equals to minus 1 over s squared. We have another example that states that find the derivative of y equals to s cubed plus 5 using first principle. Our first step as usual is to add our data y and our data s. So our equation becomes y plus data y will be equals to s plus data s in bracket raised to power 3 plus 5. The next step is to expand our bracket s plus data s raised to power 3. Doing so using binomial expansion, our equation becomes y plus data y will be equals to s cubed plus 3s squared data s plus 3s data s squared plus data s cubed plus 5. The next step is to subtract y from the left hand side and subtract s raised to power 3 plus 5 from the left hand side. Doing so, our equation becomes y plus data y minus y will be equals to s cubed plus 3s squared data s plus 3s data s squared plus data s cubed minus in bracket s to the power 3 plus 5. Now opening our bracket, our equation becomes data y because 1 and minus y have equated as we are left with data y on the right hand side. So data y will be equals to s cubed plus 3s squared data s plus 3s data s squared plus data s cubed minus s cubed minus 5. Our right hand side will simplify further to 3s squared data s plus 3s data s squared plus data s cube, because s cube and minus s cube, 5 and minus 5 is going to equate that. So we are left with data y is equals to 3s squared data s plus 3s data s squared plus data s cube. At this point, we divide through by data s to get data y over data s. Doing so, data y over data s will be equals to 3s squared data s divided by data s plus 3s data s squared divided by data s plus data s cube divided by data s. Simplifying, data y over data s will be equals to 3s squared plus 3s data s plus data s squared. At this point, we are going to find our dy over dx, which is equals to the limiting value of data y over data s as data s tends to 0, which is also equals to the limiting value of 3s squared plus 3s data s plus data s squared at data s tends to 0. As data s tends to 0, data s will be equals to 0. So the part of our equation that still has data s will equal to 0. That's 3s data s will be 0 and data s squared will also be 0. So we are left with dy over dx is equals to 3s squared. Our final example states that differentiate with respect to s, y equals to the square root of s. Solution. First of all, we write down our equation y equals to the square root of s. Now, inputting for data y and data s, our equation becomes y plus data y is equals to the square root of s plus data s. At this point, we are going to subtract y from the left hand side and subtract the square root of s from the right hand side. Our equation becomes y plus data y minus y will be equals to the square root of s plus data s minus the square root of s. Now, to get data y over data s, we divide both sides by data s. Our equation becomes data y divided by data s will be equals to the square root of s plus data s minus data s divided by data s. Now, to simplify our right hand side, we are going to be using our knowledge from SOD. We will be multiplying the right hand side by the conjugate of the numerator, which is the square root of s plus data s plus the square root of s. Now, multiplying the numerator and the denominator on the right hand side with the conjugate, our equation becomes data y over data s will be equals to the square root of s plus data s minus the square root of s divided by data s times the square root of s plus data s plus the square root of s divided by the square root of s plus data s plus the square root of s. Now, looking at our equation carefully, we will observe that we can simplify our numerator on the right hand side to the form a squared minus b squared, because we know that a squared minus b squared is equals to a plus b in bracket a minus b in bracket. So using that knowledge to simplify our numerator becomes in bracket the square root of s plus data s squared minus the square root of s squared divided by data s in bracket s, the square root of s plus data s plus the square root of s. Simplifying our right hand further, the square root of s plus data s squared minus the square root of s squared will become s plus data s minus s, because the square root and the square is going to cancel out. So our equation becomes data y divided by data s will be equals to s plus data s minus s divided by data s multiplying in bracket square root of s plus data s plus the square root of s. Our numerator on the right hand side becomes data s, because the s and the minus s will cancel out. So we are left with data y divided by data s will be equals to data s divided by data s in bracket the square root of s plus data s plus the square root of s. Simplifying further, our equation becomes data y over data s will be equals to 1 divided by the square root of s plus data s plus the square root of s, because data s in our numerator and the data s in our denominator will cancel out. At this point, we are going to look for our dy over dx, which is equals to the limiting value of data y divided by data s as data s tends to 0. It will be equals to the limiting value of 1 divided by the square root of s plus data s plus the square root of s as data s tends to 0. As data s tends to 0, data s becomes 0. So our equation becomes dy over dx will be equals to 1 divided by root s plus root s. Dy over dx becomes 1 divided by 2 root s, or half s raised to the power of minus half. Here are some exercises for you to try at home. For more insights on the topic, you can check out our Hidden Facts Further Mathematics textbook, chapter 29. You can easily get the hard copy or the soft copy at the website written at the corner of the screen. Thank you.